Good day once again, and welcome to today's physics class. In today's physics class, we are going to be providing solution to this question on projectile. And the question here reads, a ball is projected horizontally from the top of a 45-meter high cliff with a speed of 20 meters per second. Calculate A, the time it takes to reach the ground. B, the horizontal distance covered before hitting the ground. Good. Now, for us to have a proper understanding of this question, I am going to draw the diagram on the board. So let us use it to illustrate it, because we are told that what the body was dropped. That means the body has been resting on the cliff. Then it was released. That's where we're having what? A horizontal projection. Now let's look at the diagram. What we have here, we're already given that what u, the initial velocity. Now this is what ux. This one is what horizontal velocity, is not u of y. This one here represents vertical motion, while this one represents what the downward motion. So this here is what 0. This one is 0 at the top. Okay. Now the h here is the height of the cliff. The h there is what 45. Now let us draw the diagram, since we already know the questions we are asked to calculate. Let's go. Now, from the question, we are told to calculate, okay, u there is what 20 meters per second. Now, let's assume this is a cliff, okay? If this one is a cliff and the ball is here, the ball is released here, and we are told that this cliff is 45 meters high, okay? Now, when the ball is released, the ball will come, it will take a parabolic path. It take a parabolic path, then gets to the ground. Then it will hit the ground here. Now, at this point, the uy, that is for the vertical motion, here is what 0, because the body, this is the ball, okay? This is the ball here. The body is what released. But it's coming down, moving with what? The horizontal velocity, which is what 20 meters per second. Now we are asked to calculate the time it will take to drop to this place. So we have here, we are also told to calculate the range from here to here. This is the point of the building. This is the level. This is the level of projection. So this is the range, distance from here to here. Now this range here will give us what? The x, then that is the xx. Now this xs is setting as saying ux multiplying t, and that t is the time of flight, the time it takes to come to the ground. Now let us consider the vertical motion from this projection. What you do now, vertical motion, remember the height of the building to get the time. Remember this equation of motion where we have h, it will now become h now equal to what? Ut plus half gt squared. This is what? Plus half gt squared. Why? Why am I putting plus here? Because the object is dropped from a height and it's coming down. So it means it's falling freely under the influence of gravity. That means falling under gravity. Now remember that was this u of y, this one is the u of y, okay? And then the initial velocity at this vertical motion, which will be 0, which means our h is equal to what? Half gt squared. Now we know that our h here from the question given to us, the h there is what? 45. We have 45 equal to half times acceleration due to gravity is usually 9.8 times t squared. Now let us calculate for that. Now we can cross multiply. We have 90. 2 times 45 is 90, equal to what? 9.8 times t raised to power 2. That's t squared. Then to get our t squared, we divide both sides by 9.8. It give us 9.8 here gone. Then this one will cancel that. Then we have a t squared. This is setting and saying 9.8. Then t squared is equal to 90 over 9.8. Now let us divide 90 by 9.8. 90 divided by 9.8 will give us 9.18. This will give us 9.18. Then your t is now the square root of 9.18. So let us press a calculator. It will give us 3.03 seconds. So we can approximate time to be what? 3 seconds. That is the time. Now, to get your range now is now what? The initial velocity, which is the horizontal velocity with which the object was projected, multiplying by the time. So which means your range, which is your ux, that's your range here, ux multiplied the time, to now give us 20 times this approximated time, 3. The answer gives us what? 60 meters. That is the answer to the question. Now, let me tell you one thing about projectile motion. In projectile motion, two independent motions are considered. So, the force of gravity only affects the vertical motion. Now, an object released from the height will continue to move with a constant velocity to the ground, while the initial velocity is always what? At 0 at a particular height where it is dropped. So if you find this class very interesting, help us to share this post and do well to like, comment, also subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.